Fake news can be defined as fabricated stories with no verifiable facts, sources, or quotes. To put it simple, it can be assumed as clickbait to mislead readers. On the other hand, some news may include verified facts but are written using language that is deliberately inflammatory, leaves out pertinent details, or only present one viewpoint, thus referred as misinformation. Fake news and misinformation spread like wildfire, especially on social medias, and can cause several problems such as analyzing wrong data and create distrust between sources. This might lead to confusion to determine which source is more reliable. With this, infodemic arises and things get straight to be difficult than it initially was. Thus, the question has been pointed out. How can we help to curb misinformation and make tools smarter to combat infodemics?
Our team, Thinking Tech, came up with a solution for this matter, which is a fake news detector. We will create an automated web scraper using Python to fetch the content and information of a specific website or from a keyword given by a user. Contents from the trusted sources are extracted, transformed, and loaded into our ground truth datasets. Machine learning will be used to compare and determine the integrity of a specific site, and the result shall be stored in AWS document-based database. This allows the data and information process to be stored properly, independently from the platform, and can be used when needed. The platform will also have an aggregated feed of news that the systems has been flagged as fake or deemed unreliable news at a glance for the user to see.
Due to proposed web scraping, the solution can generate a few critical benefits upon implementation. First, the authenticity of news can be identified whether if it is genuine or plainly fraud. Next, news that has been tested and identified as hoax will be listed out by the system, which will convince the user to perceive that the following news cannot be trusted upon viewing. Also, the system can be a benchmark in identifying genuine sources, which can monopolize trust on myriads of sources, whether if it is trustworthy or not. Genuine data extraction, news authenticity testing, and trust of sources will play a major role in identifying genuine news. Access to the right information at the right time in the right format will be assured, thus will be an excellent solution to curb misinformation and combat potential upcoming infodemics.
Okay, so now we'll be explaining more detail about the architecture and the services that we have chose. So basically, we have chose for several services. Okay, number one is EC2. As you can see right here, we are using it to host a backend server as an endpoint gateway. As an API gateway to expose the endpoint. Right. So generally, this backend server will expose the endpoint to the client-side applications. All right. In addition of that, this backend server also is host another services which is SageMaker. Okay. So SageMaker services will be hosted in the backend server in this server. All right. So basically, this backend will triggers all the related functions in Lambda functions to trigger certain events. Okay, for example, is in our cases is scraping the website and also to analyze the documents from user input. All right, moving on to the next services is we're using Lambda. Okay, as I mentioned before, we have functions that will be triggered by the backend to make certain events. Right. In these Lambda services, as you can see here, we have actually a few list of functions. Number one is to scrape the website from the user input itself. Okay, for example, in the client app application, a user will input a URL that they desire to analyze. Is it true or is it a fake about about a certain topics? Okay, and then the backend server will trigger this function here um, to to make automated scraping about the website itself, right? So in this function, we coded in Python with a library we library called newspaper 3K, like VS4, like rejects expressions, and more. Alright. Okay. So basically, this function will script all the text that have in the website, and will automatically return the response to the backend server itself. So after that, the backend server will handle the process and pass to another certain events, right? So that one we will be explaining about that more in detail later. Alright, so the next function that we have is called TextRack. Alright, so this comes with the third services that we have chose, which is TextRack. It's basically to analyze and make a text processing to analyze data in the documents and images. Alright. So when the user input any documents or images that have forms, it can have a table, a layout, or maybe a text file itself. So the text track will extract the data from the document or any file regarding in that specific input, and then it will be sent to our fourth services, which is S3. So as you can see here, so after the text extract all the details, the file, the response will be automatically will be stored in here. So as you can see here, there are tons of documents, right? So after the documents have been sent here, and then a CloudWatch event will be triggered if a new document have arrived in this bucket itself. So what will TextRack do is actually will take the new document and make an analysis about the document. So roughly about 10 to 15 seconds, depends on how small and how big the document is. It will then will produce a new folder regarding about the documents. Right. For example, here, if you go here, as you can see, this is actually a automated by TextRack, and we generate it automatically from the TextRack. Right. So we can receive a different types of files here to be sent that we can be sent to another services. For example, SageMaker to make a prediction, or maybe to make a text pre-processing.
Hi, I'm Farzufian, and I will explain on how we used Amazon SageMaker to implement our machine learning model training of the model for our prototype approach. So first, we use notebook instances to do exploratory data processing, to experiment with the data that we get from Kaggle that we use to train our model in this prototype. So we use notebooks. So we use this notebook to explore the data, do visualizations, and decide which model to use. It is really handy because it is all in the cloud, and we have this Python notebook running, which takes time to open. So this is where I use notebook for text shaping, and we use recurrent neural network with a bidirectional long short-term memory, or LSTM layer, and a single sigmoid output. So this is how I use it to explore the data, see the histogram, and then feed a tokenizer, which will then be used to tokenize the input of article text from the user before handing it into the model to do predictions with the same tokenizer which has been fitted for the training dataset. And it's really useful because you can just run Python scripts in here without the fear of having low-end
computer low processing power in our own laptop, or like weak networks, because everything is in the cloud. And so after training, we deployed a model. We have the model here. So this is our deep learning model, and we have launched also an endpoint for that is currently up and running and can be used from our front end application, sent to the back end, and does the processing necessary before sending to the endpoint and get the prediction back. So that's all that we use. Oh, also in our notebook instance, we use Git repository, which is really handy because we can do collaboration with all our group mates, so that we can have all the codes in one place in our repository in GitHub. And that's really handy. Okay, so that's all that we use for Amazon SageMaker.
Alright, so in the next session, I will be explaining about the backend of our service. Alright, so basically a backend handles all the process that the client does not see, which is everything to connecting to the database, fetching data, inserting data, connecting to other services. And as for our implementation, we are using Node.js. So for a specific reason why we're using Node.js is because it is asynchronous, which means that connecting to other services via HTTP is very fast and easy, because we don't have to wait for the completion of the response to proceed to the next instructions, so which makes it very scalable and fast. And to pair with Node.js, we actually use this library called Express, and this is a very popular combination of Node and Express, and this is what we're using for the services. And another reason we're using Node.js is because it is rich in libraries. We can use a lot of libraries to make our lives easier and make the experience of using Node.js better. And some of the libraries we use is we also use the software development kit from AWS. So this is responsible for connecting and communicating to the third-party services such as the Lambda, the S3, and the SageMaker. Alright, so one of the important rules of the backend is to trigger all the third-party services. So as you can see here, the code right here, the code you're seeing right now is actually running on the server, and you can see here, it's currently running and being accessed by the client. So this code has a lot of responsibility. One of the most important rules or responsibility of this is connecting to the Dynamo database. So this is all the entries that we currently have, and this is all handled by the backend. So which means the backend is responsible of managing the data, controlling the data, and providing the other services with the appropriate argument for these services to do their tasks. So basically, in our case, our implementation, the backend is like the central hub of everything, where your data comes in, and the backend is also responsible to handle where your data goes and what to return to the user, and it is also responsible for handling the connection error. So such as, for an example, if the connection to S3 fails, the backend is responsible of noting the user or throwing the appropriate error to combat the problems. And yes, that is the role of the backend, and I can show you the bit of the source code here. Alright, that is from me. Thank you. Today we're going to demo our prototype. So as you can see right here, this is the fake news detector. So as you can see, this is our user interface. We made this using Vue.js, which is a front-end framework from JavaScript. So how this works is,
for the demo, we're going to be two URL. So the first URL is, so take note that this two URL is from our dataset itself. So the dataset, the test dataset.
Testing
dataset. So the model doesn't see the URL yet. Alright, so
we're
the
just
first
gonna
URL.
put in the first URL.
So we're gonna send it. And since we don't have a loading, so that's why it doesn't output anything yet. So let's take a look here. So as you can see here, the model tells that this URL is actually legit and authentic. So you can see the bar meter is going up. So we're gonna send. So let's take a look at the back server. Alright,
Yeah.
so this is data.
So
So
this is the prediction here, and as you can see here,
prediction is there's not going up, so it's actually the system model says it's fake.
Yeah.
So I think yes. So if you're gonna take a look here, the journalist will also make a fact check, right? And so yeah, so anything it will tell, it will make decisions.
The marketability of this fake news detector is rather ambitious. On the early stage of marketization, we will hire fact checkers to double check the authenticity of each news sources. Fact checker will aid in determining the status of every news, and our machine will then commit deep learning in order to adapt and apply the methods of trends advocated by the fact checkers. At this point, the system will be more automated in terms of handling news authenticity. Upon achieving automated predictions, the system will now have a more accurate authenticity prediction. User will then try to execute more input to check whether their sources are genuine or fake. In concluding news authenticity, users will then can determine which journalism to trust. Higher authenticity percentage against accumulated news count can be considered as a more reliable and accurate source to be referred. Accurate news sources can have the data extracted for extensive research purposes. The researchers will have a great benefit in this scenario, as resources in expensing can be reduced to only what is needed to be expended on. Thus, this will bring forth an impact of more efficient costing. Not only that, accurate news will also determine journalism that are considered as reliable sources. The said journalism will have more subscription and viewers to their written news. But in order to gain official recognition as a reliable source, we will charge them with an annual licensing and certification. As for this method, it can be said as a win-win situation because our system can generate revenues via news checking, and the journalism will gain their respective publicity value of more subscriptions. Because of we will be charging the licensing and certification of authentic news source, many other journalists will also want to have their sources to be recognized. By that, we can gain greater volume of data and will benefit on future analysis. Upon gaining high volumes of data, we can scale the system to machine learning oriented journalism, as the report of fact-checked news will be fed into the trained dataset. With this, the system can be a benchmark on determining news authenticity and potentially monopolize the market within the news fact-checking scope.